Hi, Julia, and let's break down the animation. So, first off, this looks really good. And I think motion-wise, it's really nice. And you've tracked the shapes pretty well. So, what can we do here? I've tried to do some things and to experiment a bit. So I try to do this. And also I try to do some small changes. And what are the main things? So if we want to make fire and make it look like fire, there are a couple things to keep in mind. So fire breaks into particles, and fire is pretty fast, which you can see in these examples, and this example, and even in this live action footage, which is slow motion fire. It's not real time. Real time would be even faster, more like this. And what are the things to keep in mind here? So the particles that break up from the fire, they're usually pretty hard to stop. So the fire usually goes up unless there are forces preventing it from going. And it can swirl, but you can notice that just to make the fire swirl and kind of rotate, you need to still keep it moving and keeping the spacing in mind. So this part goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It never actually goes down from where it was. The motion that feels like going down is actually still going up, but compared to this part, it feels like going down because the part on the right outruns it. But if we take this curve, it still doesn't actually go down. Even at the last frames, it's still going up. And that's kind of one of the keys. So it's hard to move the fire down if the majority of fire is going up, because fire is lighter than air. It's hot, heated up air and gas, and so it pretty much always wants to rise up. And so the cases when we don't rise the fire up are usually the cases when the force initially pushes the fire more to the side or according to the curve. And the same with changing direction. So the particles that started moving to the left are quite hard to make move to the right. You would need quite a strong gust of wind to do that. So now if we look here, what's the thing here? So one of the things is that at some point, pretty fast, some particles have fast initial momentum, and then they suddenly stop and go in a completely different directions. So lots of energy to the left, lots of energy to the left, and then lots of energy to the right. And that's possible, but it's not really characteristic for fire. Fire tries to maintain its direction quite a lot. And The second thing is that fire tries to break into particles, and right now you're keeping everything very close to where it started. So when you're breaking particles up, you keep them connected to the mass for really, really long. And so it creates this trail instead of letting the fire continue its path. So 1, 2, 3. See, the spacing is quite big, but then the fire just stops. So what would probably happen here? Let's test things out quickly. So say we have this mass and it's going up. So we go, we go, we go, we go, we go, we go, we go. Let's take this mass. So we go, we go, we go, we go. You see, we accelerate it. Go, go, and then we switch to the left. We go to the left really fast, but we haven't really prepared going to the left. We were moving to the right quite fast. And then we suddenly go to the left. So here, we'll need quite a bit more time to transition. And since we had that much energy, the particle would also need quite a bit of time to stop. So this particle that breaks up here, you see, you're giving it momentum, a lot of momentum to the right. So it will not suddenly stop and go to the left. So it goes 1, 2, so 3, probably 4, 5. But also let's track this particle before. This particle was part of this mass, and this mass is going up pretty fast, and then it suddenly goes to the right almost in a straight line, which again is a bit uncharacteristic of fire. It needs quite some time to react to stuff, individual particles at least. So it will probably go in a curve, still rising up. Maybe even faster at the start. We need to make the transition more believable. Okay, maybe something like this. And then again we have the next mass. It becomes this particle, which will probably still continue some of the motion. So 1, you see, and it's going to the right. We haven't really built up the motion to the left just yet, so we'd move it slightly more to the left. Here, a lot of momentum. You're adding a lot of momentum, and then we're suddenly changing it, which again feels a bit sudden. It will probably need quite more time to slow down. And then here again, we're going straight up, and then we're going to the right very fast. Then we're not going to the right, then we're going to the right really fast. So how would it probably happen? We would, instead of trying to move the same mass that was on the left to the right, we can instead start building the mass as the foundation, at the base, which actually starts going to the right. And that would make more sense, and that would make the path of the particle way simpler. And then you see it again stops in the air, even if it had a lot of momentum. So we probably need to continue the motion for quite some time. And the same thing with this particle here. So you see, you're dragging it all the way from the very center to the all the way to the right, which, I mean, potentially is possible, but quite unlikely for the fire. So you see it's going and rotating to the left actually, being pushed to the left. So it doesn't make sense for it to rapidly go to the right. It will probably try rising and dissipating. And the motion to the right can be done through the next particle, which is going more on the curve to the right. Oh, tracking around thing. So instead of trying to move it all the way there, it's just a particle that's rising way slower. And then, if we do these changes, we'll get a better sense of fire. And if we stop keeping these links connected for a really long time, it will also start looking more like fire. So you see, it starts breaking up, and like the frame it goes the same, the next frame we don't have this connection because that's less characteristic for the fire. And you can kind of compare it here. You can also notice that the fire is usually more chunky towards the bottom, and we don't want to introduce too many holes at the foundation, at the base, or introduce them too early, otherwise we can't really expand them, which happens in some of them. You see, this thing, it's already so big so that we don't really get a change in volume. And it also keeps our shapes very more smoky, so very small, much bigger, rather than fiery, which is usually more like either slightly randomized or kind of go in between thick and thin, and usually we get a bit more in the middle to the base, which isn't the rule, but the observation kind of. What else? What else? What else? What else? So, again, it's a really good fire animation. I tried doing some small drawers. So this is for shape language basically, and how scenes can dissipate. So we kind of keep the particles moving and rotate them a bit. So probably even not go that far to the left. So I keep it moving, I keep it rising up, and this part is still moving and it's still rising up. So we go 1, 2, 3, 4, and we can have a deceleration, but it's not going like this exactly. It's more like this, and we decelerate, while the other part is just faster, and that's how we get rotation and all this swirling. You can notice some shape changes here. So trying to get a feel of how it goes around this ball. How does it work? What's there? Because it has volume, it has surface, and it's burning somehow. So a couple frames where it goes like this is not really clear how the surface is interacting with the fire, or what's even the source of the fire. Because it's usually something on fire, or it's gas, or it's kind of certain, I don't know, nozzles. So there is always a source. And if it's a shape, a form burning, the fire will kind of follow the form, at least at the start, and then it will go and become its own scene. So we can always go and imagine, okay, so how does it actually cover the object? What's the logic behind it? Again, how does it follow the object? And then, of course, we have all our usual stuff about variety, experimenting with the shapes. We can still keep it kind of the same idea. Just trying stuff out. For this, for example, we can simply add some mass at the base. Maybe something like this, so we can still cover the ball. And then if we had this frame, this goes up, this still goes up, this goes up on a curve. So we get something like this. This gets stretched out. This hole is going here and raising the shape out. This goes up to the right a bit. So more like this, and we can raise it more. Maybe not that extreme on the left. Maybe something like this. So the top goes and gets erased, becomes a particle. We can even break it up. Honestly, we don't have it. We don't need to keep it fully connected. And it can probably go higher up, honestly. This goes here, rotates, and we're rising. We're making the smoke rise. And then we can still keep this shape rising and just push it to the left as well, but keeping that momentum. Okay, 1, 2, 3. Still keeping it generally rising up. And that's specifically for more fiery rather than smoky animation. So if you want to have smoke, you can keep the shapes longer and keep them connected longer. That's kind of one of the key elements of smoke. Long connections. It stretches out and thins out for a long, long time, while fire kind of breaks up a bit faster and the shapes dissipate much faster. Rail file is actually really fast, but for the sake of stylizing, we can keep it for quite longer. Okay, I think that's a lot and enough of me rambling. I think the animation is really good. I think it's really cool. I think we can delay these holes a bit. I think you're making them quite big pretty fast at the start, and they don't need to start from the very beginning. They can appear in the fire, like in the middle, and they also travel quite fast, but we can stylize it a lot and let them rise slower, and this gives you a smokier feel as well. So with fire, we start introducing negative space and holes kind of later on in the animation, not at the very base, but rather somewhere along the middle to the tips. And with smoke, you can introduce the holes and negative spaces quite early because the nature of the element is different. Fire tries to keep itself more solid near the foundation, near the source. And that's the good part of it. What else? What else? I mean, you can see it here, kinda. So we're introducing these negative spaces, but they're not appearing at the very bottom. They're starting kinda in the middle. So this part is more chunky, and then we start introducing these holes when they're going higher. And we can actually try and track them to understand. So 1, 2, 3. See, they follow these curves, and that's what making it swirl while we're still actually going up on all the edges. Ye- huh, huh, huh. I think that's pretty much it. Keeping it moving, not dragging it along with the main mass, letting them go on their own way, and you'll be fine. That's it. Wish you good luck with your animations, and see you later.